Okay, here's a screenshot of the reactions and rates PhET simulation that we'll be using for this Chapter 15 laboratory experiment. Chapter 15 starts to introduce really some of the fundamental aspects of a chemical reaction, and this simulation enables us to look at some simple things of looking at balls and spheres that simulate atoms and how they bump into one another. And what I've chosen here is the single collision tab first. And I just want to walk through some things here, show you a few things. In the description of the laboratory that I'd like you to complete will then be some more activities. But I want to just give you a little bit of a feel and a few descriptors here of what we're looking at. So here we've got a reaction of an A molecule that's going to react with a B and C, where you got maybe two atoms that are tied together. And this is, as it explains, a single collision. And notice a couple things here. So you got a reaction diagram, which you're starting with the reactant going to products. There's an activation energy, so the energy has to get over this hump for a reaction to occur. So let's just kind of visualize and see what happens here. So if I go over here to the pinball thing, pull it back, notice how I'm actually supplying some energy to this system, and notice how that total energy actually increases. So if I just pull it back just a little bit and let it go, it bumps into that molecule, but there was not enough energy put into that yellow molecule, that A ball, to actually get over the hump, So if I had pulled this back more, then I would have placed enough energy. Now, in terms of chemical reactions in reality, we don't have a pinball control. So how do we get more energy into the system? Well, the most common way is that we add heat. So if I raise the heat or the temperature of this reaction, notice how the total energy of the system is going up. But it's still not enough energy. It hasn't gone over the activation energy to actually react. So that yellow ball is still unreacted. Notice up here there's a separation in that as it comes together, it actually corresponds with this gray line, and it goes up in energy, it gets as close as this, but that's all the energy there is, and it falls back. So let's raise the temperature some more. So if I get way up here, and if you watch the separation, it actually gets really close out here, but it's still not enough energy for it to react. So if I raise the energy some more over that hump, now it reacted. But then notice the situation here, and this is one of the important things as far as equilibrium of reactions, in that there was enough energy to get it to react to go to this side, but then notice there's enough energy when these things bump into one another to go back to this side. And that's what we see happening over here. Okay, I'm going to reset this. And I just want to show you one other thing that gets us more to a reality here. So if I were to do something like this and pull it back, so now this is a case where I delivered enough energy and I let it go. So there's enough energy in that system with this A ball that I should have gotten a reaction. So this is the other aspect of kinetics, in that I have to have a certain amount of energy, but the geometry of reaction has to be correct. And this is one of the occurrences that we experience a lot with chemical reactions, where you'll heat something up, but it takes a long time to react. And we have to wait for the right geometry to occur. This is a critical thing when you start talking about biochemical reactions and trying to get reactions to fit into receptor sites. And then this is where things like proteins and enzymes can really help control the geometries. But here we're just looking at two things bumping into one another, and that for these things to react, you've got to have this ball, the A, react right on the right geometry to get that to react. And so we'd have to watch this for a long time, and eventually it'd bump into one another in the right geometry and react. So I just want to go through that. To help this process, this is where concentration really comes into play. So if we add more of these balls, more of the atoms or molecules, then there's going to be more of an opportunity and more of a higher probability of some finding one another and in the right geometry and reacting. Okay, I'm going to stop this this recording right now, just so the file sizes don't get too large. And then I want to talk about the next couple tabs, the mini collisions, and then the rate experiments, which will really guide or help you through your experiment that I'll have you do for this chapter.